Hey guys, welcome to another episode of Steam at the Library. I'm Cody from the Okanagan Regional Library, and today we're going to be taking apart a Coffeemaker. It's going to be one of those Tassimo units with a barcode reader. Now, the barcode reader itself is actually very damaged on this unit, and I don't want to be replacing it, so my goal is going to be salvage. I'm going to be taking it apart for parts. I want the pump, and I want to see if there's anything else I want out of this. So, let's get started. So the first step is popping it open. Now, I've never taken apart this thing before, so there's going to be a bit of a learning process, but that's something we're going to learn together. Alright, let's go. So the first thing you'll notice is that there aren't any screws on the outside of this unit. So the first step I found was to try to find any screw holes that were hidden. A good place to look at first is generally underneath the feet. Now, the Coffeemaker is not designed to be serviced by the end user. You and me, we're not supposed to be taking this thing apart. Taking off the feet, we saw that there wasn't anything, so my next step was to figure out how the case connected together. Now I have these little plastic shims. Shimming up the cover a little bit let me peek and figure out how it all clipped together. We have two sides, one of which I'm going to call the electronic side, and one of which I'm going to call the pump side. The electronic side has the main circuit board on it, and the pump has the pump. So a good first step when you're working with taking apart stuff is to disconnect as many connectors as you can before proceeding. That way they're not going to get tangled up and in the way. So I'm going to unplug all these wire harnesses. These are just wires with plastic clips on the end that clip into the circuit board, connecting it to all the sensors, pumps, and other components. You can just pull on these, they generally come free pretty easily, and once those are free, the circuit board just unclips with the plastic clips. As always, be as gentle as you can afford to be, as more force means more risk of damaging your hands and the components. Now that we got the wiring harnesses loose and the circuit board out, we can also just pull out the water level sensor for the tank. This is a magnetic sensor. I'll show you guys how it works in a bit here, but for now you can just loosen it off the clips and remove it entirely. In the interest of taking things apart from the outside in, I'm going to work on the other side now. Now we've got everything that could be damaged by water out, our goal is to start working on getting the plumbing and the pump out. Newton's third law of motion is that every action is met by an equal and opposite reaction. When you pump water through the coffee machine, the water exerts a force opposite the direction of travel of the water. This motion could cause the machine to walk around on the countertop, so in order to absorb that force, this is all on a spring mechanism to dampen the violent pumping motion. This makes it so the force is diffused rather than sharp, so the machine doesn't walk around when the pump is running. So to remove this, we're going to have to take out some springs. I just used a pair of pliers, pressed the springs down, and just pulled them off the housing. Our next step is to get this carriage completely free. It's being held in place by wires and hoses. The hoses are held on using cable ties, so these can be cut. If you're doing a repair on this machine and you needed to take the carriage out entirely to do so, you would want cable ties on hand to replace the ones that we're removing. Your mileage may vary if you take apart something similar in the future. Now the hoses were pretty well infused onto the plastic housing at this point, so I had to apply quite a bit of force to get them off. So removing those allowed me a little bit more room to pull off the wires, which turns out required quite a bit of force to get free. Now we've got it a little bit more loose, I wanted to recover the sensors that are plugged into the top and the bottom of the heating element. There are hairpin clips holding in the thermistors, so those can just be removed with a pair of pliers and the thermistors can just be pulled out. Using a pair of pliers, we can disconnect the rest of the wires and we're free. So I found that these had a very interesting mechanism on them. There are thermal fuses on these. So if we take this apart, we can see that there's a little brass cap on the inside that's held into place with 4 pins, and the bulgy side of the cap presses into a pin going into a switch. When this part heats up, the metal expands, and since it's a little cup shape, it pushes up into the switch, breaking the circuit. It's a piece of failsafe engineering that I greatly approve of and found very interesting. The valves on the end of the heating unit are just friction fit in, you can just pull them out, and to check which direction a valve is running, you can kind of blow into it and find out which direction the air flows. Let's have a bit of a valve trumpet solo. The next step is to remove the top of the unit. This is clipped in 8 places, so you can just pry those off and get the top completely free. Once we've got the top loose, we can just have a look at it. I saw that it had screws in there. Once again, this unit is not designed to be user serviceable. If you were intended to take this apart, then it would have a Phillips or flathead screw. Luckily, I had the right bits. Otherwise, I'd need to do a lot more damage, drill out the screws to get this apart. Once we've got the screws out, we undo 2 latches and then pry on the front because there's a clip there as well, and we managed to get the top part open so we can see the internals. Everything in the top unit is simply screwed in. We can easily take everything out there and salvage what we need out of it. We're nearly done. Now, to check if there were any parts I wanted out of the top there, I needed to pull the pin out of the hinge. Fortunately, I had a big pair of pliers. This required a decent amount of force, but this is the intended way of getting it apart. It turned out that there wasn't anything worth saving out of there, but it was a good exercise anyway. The last part that's connected to the machine was a sensor on the bottom. Now, I couldn't see how this was put in, but trying to unscrew it didn't do anything. Trying to pry on it, I had to use quite a bit of force, so I wasn't sure about it. But I managed to figure out that it was, in fact, a friction fit. It just required a fair amount of force to get it out. So I cut out sections here, but let's go through a fast-forwarded version of the entire disassembly process so you can see what you missed. Okay, so now we see how all the parts fit together. Now we can talk about what the system's actually doing as it runs. So let's have a look at the plumbing system first. So here's how the water flows through the plumbing. Water gets pulled in through the water tank and passes through the flow sensor. From there, the water is pulled into the pump, which pushes the water forward as well as pulling it in. The water passes through the first valve at the bottom of the heating unit. There is a pressure relief valve here that just goes back into the water tank. A thermistor checks the water temperature as it goes in. Then the water passes through the heating unit. There's a second thermistor at the top of the heater, which checks and verifies that the water is coming out at the right temperature. After that, the water passes through the second valve, and there is another pressure/steam release valve at the top. Finally, the water passes through to the top of the unit and the output. When this system is pressurized, there's a pin that pushes out that latches the lid closed, keeping you from popping open the unit and potentially getting scalding hot water on you. Helpful. The water exits the top area, passing through the Tassimo pod, and you get coffee. So now that we have a sense of how water flows through a system, we can talk about the control systems that say when and how to put water through the system using the pumps and sensors. So let's get into the electronics. So looking at the electronics, the power enters in, passes through a switch mode DC converter, and it powers up this ARM 32-bit chip. This microcontroller is the brains of the operation. It tells the Coffeemaker what to do in various situations. Like, say for example, you press a button to tell it to start making coffee. Every sensor and every output device is wired up to this microcontroller. It would normally be overkill for an application like this, but with the barcode reader, you actually need all that extra brains that 32-bit chip gives you. Here's a demonstration of what the thermistors at the top and bottom of the heater do. When put in 50-degree water, the resistance is about 3.8 kiloohms. In 25-degree water, the resistor is about 10 kiloohms, and in ice water, the resistance is about 24 kiloohms. Lower temperature means more resistance. The microcontroller reads the resistance to say what the temperature of the probe is. Here's a demonstration of the read switch in action. Bringing a magnet close to it closes the circuit, so a magnetic float in the water tank allows you to sense when the water is low without actually having to look at exposed sensors outside the casing. Here's a demonstration of a switch in action. Pressing the lever down closes the circuit, dropping the resistance to 0. There's a mechanism in the lid that presses the switch whenever the lid is latched shut. Here's a demonstration of how the flow sensor works. Water or air passing through the sensor causes the paddle wheel to spin, and the magnets on the paddle wheel are picked up using sensors to determine how fast water is moving through it. This allows you to determine the flow rate of the water so you can dispense a very precise amount. There are also 3 buttons on the back of the circuit board. These are used to control the machine, tell it when to start making coffee, etc. So that's the sensors. One last thing to look into is the output devices, namely the pump and the heater. This 120 volt AC pump is the whole reason why I took apart the machine in the first place. I want a pump, and this works pretty well. All you need to do is supply wall power to it, and it'll plug along, supplying water to the other end. This heating unit has 2 thermal coils on the inside. When you supply power to it, they resist the flow of electricity, causing heat to be generated. This heats up the water, and as water passes through it, it heats up water to the correct temperature for making coffee. Technically, there's one last set of output devices, 4 LEDs on the back of the circuit board, which can give the user information about the status of the machine. Whether it's running, whether it has low water, whether it needs cleaning. And that's all the major components of the Coffeemaker and how they work. Okay guys, that was a lot of fun. We pulled out a lot of cool salvage out of the machine. I've already got some ideas what to use that pump for. Alright, so if you liked this video, make sure you hit the like button and subscribe to our channel if you want to see more Steam content like this. As always, have a great day and enjoy!